Programming Throwdown, episode 111, Real-Time Data Streaming with Frank McSherry. Take it away, Jason.
Hey, everybody. So this is going to be a really, really interesting episode. A lot of folks are interested in big data. Big data is still hugely important. It's still growing at like a really, really fast pace. There's so many companies that are figuring out how to manage a lot of information that is, coming through, and how to harness that and how to use it to make better products. And so we're here to talk with Frank McSherry, who's the co-founder of Materialize, who's going to really kind of walk us through, really what is real-time data streaming, how that works under the hood, and how everyone else can kind of get their hands on this tech. So thanks a lot for coming on the show, Frank.
Oh, it's not a problem at all. It's my pleasure.
Cool. So how are you handling the COVID situation, the work from home? How has it kind of changed your day to day?
Yeah, well, it's maybe unsurprising. It's changed everyone's day to day pretty substantially. Mm-hmm. We went from being a group of people who are basically all in the same room, more or less. We had a sort of 16-person office that everyone showed up at and worked, and had a certain collaboration style, and that sort of pivoted 180 degrees to everyone is somewhere else. And it's in some ways good. Like from my point of view, we need to be a lot more thoughtful about our communication and our processes and stuff like that. You can't just yell at someone to try to figure out how a thing works. You have to ideally write it down, and everyone can see at that point. And I know, but like super disruptive. Yeah.
How do you handle that situation where someone needs to ask for help? I found this is a real challenge with our team. Is it used to be you kind of just yell and whoever someone will just kind of jump in. But now it's like if you post to the chat, it's kind of a little bit more disruptive, and there's this kind of Mexican standoff among all the folks in the chat, like who's going to answer this. And I was wondering how do you deal with that?
You're right. It's definitely a little tricky. I think at the moment, at least, we're still, things are changing, of course, but we're small enough that there's still some sort of sense of ownership for who is in charge of a certain thing. That person might not be looking at the moment, but there aren't a bunch of people saying, "Oh, not me, I didn't do it." Generally, there are enough folks who are interested in sort of the health of the code and stuff like that someone will pipe up and say, like, I thought it was this, or here's a PR that looks relevant. Maybe that's where the problem is.
Yeah, it makes sense. Yeah, I think I've been telling folks to try to do point to point. Like it might be easier to message one person and that person tell you go some like it's actually this other person. Then you message the group, because you end up in this situation where potentially maybe no one answers and everyone's kind of looking at each other. But yeah, I think that all of these things and whiteboarding is another thing that I've found to be a real challenge. But all these things I think we'll be able to make, that we'll be able to sort of make progress in these areas. It's just going to take time.
Yeah, no, it makes it very clear that this is, for me at least, for sure, this was an underappreciated aspect of how do you get work done. We can certainly we're faking it a little bit now in terms of figuring out the right ways to communicate, but clearly people who are good at remote first, for example, it's impressive that you're like, oh wow, you must have some great processes in place, or just fundamentally different ones, but clearly more robust to someone isn't available for a little while, or someone's sick or something like that, and they're just out for a bit. Can your org resist that? It's neat stuff, and I hadn't really thought very hard about this at all beforehand. And
yeah, definitely. Yeah, it's wild how it just kind of happened right away. I mean, I still actually have a bunch of little tokens and picture frames and stuff at my desk. I think. I mean, I don't even know if someone cleaned them off or not. But it's just one day we were told not to go into work, and so it's just kind of like, I wonder if it's just a snapshot of March 2020 over there. I mean, I can't even get in the building, so I don't know.
We had that for a bit. We had someone go in. We were at a WeWork essentially, and our lease was up at some time in June or so. And we had some folks go in and basically put things in boxes and put addresses on them and ship them. So you got like essentially a care package, which was the stuff that was on your desk, which is
nice.
Was a bit like, well, it's nice to have, but it's also a bit weird to think like you've basically just been moved out or something. It's
totally.
very emotionally jarring, a lot of the stuff, I'm sure, for many people for many different reasons. But that's also been
Yeah.
a big problem, I would say. Like, there's the mechanical aspect of writing code and building a business, but there's also just a big emotional tax on a lot of folks who are trying to get their head around the world being different and stuff like that.
Yeah, totally makes sense. So let's rewind from the Materialize in the WeWork, and let's kind of start from the beginning and kind of what's your backstory and what kind of led to you co-founding Materialize.
Yeah. Okay. Well, it goes back a ways. Tell me if no, that's too far. Speed it up.
No,
But
go for it. I mean, you could say, first there was the womb, and then
yeah. No, I think, like, in terms of formative moments, you went to grad school, got a standard computer science education, went to grad school, which is maybe a little less standard, and did some great work with, I thought, great work with Anna Carlin, who is this person who works at the sort of intersection of theory and systems work, and got a little bit of a taste for both, thinking about things for long enough that they make sense, but also trying to get your head around whether the thing that you've thought about should actually be turned into something that computers do, actually results in something meaningful and of consequence. From there, went to actually start working at Microsoft's research lab in Silicon Valley, which was there for, it was like 12 years or something like this. And lots of great people. This is very formative. This is a lot of really interesting combination of theoretical computer scientists and people working on systems, in principle distributed systems, but computer
Yep.
systems. And a great place to really learned a lot. Like, the people there were very strong, and you learn a lot both about the actual technical bits of computer science, but also how to think about research, how to do things of consequence. You're relieved a bit from a bunch of the academic pressures of publishing at a very fast cadence. You can sort of wait until you've actually got the thing that you think is right before telling people about it.
Yeah, were you there when MSR in Silicon Valley closed down?
I was.
Oh man, that broke my heart. I mean, I read about it in the news, and as being in another tech company, we were constantly reaching out to folks to try to hire them, but that was just unbelievable.
It was very surprising at the time. I mean, to be honest, I have sort of mixed emotions about it, in that I'm totally happy. I have to be careful framing this, but, like, it was a very comfortable place, and I do kind of like the idea that folks get moved out of their comfort zone occasionally and have to go and do new and interesting and different things. And I was very happy that I was moved out of my comfort zone, because I feel like the time after that was, for me at least, was very good. I got to do new things, think about new stuff, try different ways to the world that I wouldn't have bothered to do if that had still been around. I would have just stayed there for another 12 years on autopilot, writing papers, doing things. So I'm personally glad that I got shaken up a bit by that, though I have lots of colleagues who weren't nearly as glad. But
Yeah, I mean, I was in a similar position where had a job that I was, it was a very comfortable job, and I was getting kind of good ratings, and I had in this case, I chose to take this opportunity, but I was always you're always kind of really nervous leaving your comfort zone, because you feel like, oh, I can never really go back, and kind of taking this big risk. But there's two things that I kind of learned from my experience, and I'd love to hear what you learned from yours. For mine, I learned one is that no matter how kind of much time and energy you've put and how much you're part of the process at your current company, that when you leave, everyone else just picks up the slack. And like, I actually thought that is the team was going to struggle a lot more than they actually did. They were just fine. And the other thing is going the other direction. You can always go back, and people, if you tell your boss you're leaving and why you're leaving, and provide it's on good terms and everything, they're always happy to welcome you back. And so both of those made me feel a lot better. Now, obviously, in the MSR case, there was a going back, but I know from someone who saw that from another company that there's always really good opportunities for good people who work hard.
I think that's totally right. I mean, that was my experience as well, which is that mechanically it would have been difficult to go back to Microsoft at the time based on how things happened. But if you're good at what you do, or close enough, there's lots of opportunities out there for a lot of different folks. This shows up a bunch, to be totally honest, in the startup space as well, where we just at Materialize continually have these conversations with people. We're trying to recruit great people who have a cushy job somewhere and are a bit worried about the risk, right? The risk of, like, well, do I want to leave my job to do something that's a little riskier? What happens if in the worst case scenario? And the answer is usually, well, the worst case scenario is you just go back to your existing job or something similar. It's not like they're not going to be at your throat just because you wanted to go off and do something interesting. Generally, they're super welcome to either have you back or doing a similar thing at a different company if for any particular reason your opportunity is gone. So it's a thing that you don't. I certainly didn't think of ahead of time. Thought like, wow, it's really comfortable here, and indeed, if I go somewhere else, it's gonna be tricky to get this again. And it doesn't. It's not necessarily the case.
Yeah, that makes sense. I've heard that in the startup world, there's it's a really good point. In the startup world, there's a sense less protection. Like for example, if you're at a startup and the startup pivots and they just don't need your particular skill anymore, then you could, be let go for that. Whereas if you're in some giant company, there's almost like always some place you can go, or they'll give you time to retool, and so that can make people nervous. But the same thing still applies, that there's always kind of a ton of demand there. And so if you find some startup that's doing something you're really passionate about, you can join it with confidence.
I think that's right. I mean, that's certainly been what I've seen, and that might be coming from a position of privilege for sure, but it's certainly the case that although a startup might do something surprising and you decide you don't like them anymore, or maybe it just doesn't fit, and that's bad news. The larger world is at the moment still really excited for computer scientists, especially ones who are doing bold, innovative, startup-y things. Usually companies are pretty happy to get in touch and find something for you to do.
Yeah, that makes sense. So you were at MSR, and then did you go from there to another big company, or did you jump straight into startup world?
Yeah, no. Actually, what I did is I hadn't taken any vacation in the 12 years I had been at Microsoft. No vacation of consequence.
What? Wait, no
But
way. Are you serious?
I had taken one like a year or two before. I took about 3 weeks off, but other than that, it was all visit folks for the holidays type things. No particular vacations of consequence. Yeah,
Did your vacation accumulate? How did that work? Is there a
I
limit?
mean it's California, so they're not allowed to. It's it builds up, but it maxes out at some 6 weeks or something like that.
And so
And
you just had maxed out. You're just shedding vacation days for years. That's wild. I mean, you must be really passionate about what you're doing.
No, I mean, yeah, maybe, but no, it was just that it was. I had, I certainly hadn't at that point in my life come across like building up a good work-life balance and sustainability and stuff like that. It just.
Yeah, actually, we should do a show on that. Maybe we'll invite you. We'll invite you to talk about work
Oh, I
life,
don't
because
think people want my
that actually
advice.
is
Yeah.
something we never covered that. And now that you mention it, that's so important. It could easily be a whole hour, but
This past year has made that really clear. I think like we've had a lot of folks at the company that just getting wound up and stressed for non-standard reasons, right? Like not things you would have anticipated, not things that you sort of put on your calendar as make sure to unwind. And it's been really important for us to try to pay attention, remind people that like you should absolutely think about taking time off. Don't sweat the fact that like you can't go to an island somewhere and drink you know bright colored drinks,
yeah,
but take some time to just
yeah.
reset.
I get these automated emails from when people get close to their limit on PTO, and usually, I mean, I don't think I've ever seen them before, but now everyone is at their limit, and I think you hit the nail on the head. People say, well, I don't want to go on PTO if I'm just gonna have to stay around the house. But then they're completely burnt out. And so you almost have to kind of force people and say, look, you need to spend a week just sitting around your house doing nothing. Like you just have to, because you are just flipping out over stuff that doesn't matter. And this is an incredibly difficult time for that.
So you had asked, what did you do after Microsoft, and that was the segue into here. But what happened essentially was I concluded I should take some vacation and vanished
Yeah.
to Morocco for a little bit for some surfing,
Oh,
and
cool.
yoga, stuff like that, and just chilling out. It was actually really pleasant. It was even with the surfing and the 3 meals a day and yoga, it was a rent reduction from San Francisco, so that
Yeah.
was pretty sweet. And just started doing a bit more of like lo-fi living, I guess, like not worrying quite so. I had a laptop, had one suitcase that was everything that I'd owned pretty much, and sort of wandered a bit around. I had some work obligations in Europe. I had agreed to chair some workshops, and so did a little bit of work, but mostly just slumming around, doing some work on the side, but at my own pace.
Yeah, that's super nice. I don't know if you know Richard Stallman's kind of like lifestyle, but this is sounds a lot like I interviewed Richard Stallman a while ago, and yeah, he basically goes conference to conference, gives talks, and he asks, can I sleep on your couch? He has this email thread, like listserv type thing of all the couches he can sleep on,
Oh dear.
and he just goes from place to place meeting new people, and it sounds like a really really kind of exciting, kind of life where it's exciting, but it's also chill, which is kind of hard to get.
Yeah, it's it definitely was interesting. Like, so some of the time was going. Yes, there's of course some just hanging out and surfing and Rocco type things, but there's also dropping in on the people doing Apache Flink in Berlin and dropping in at Cambridge in the UK to work with them for a few weeks, and then eventually it turns out dropping in on ETH in Zurich, which happened to be doing a bunch of related work, work on data flow processing. They were looking at building systems that would essentially take the exhaust out of data centers. So whatever is happening in your data center, not the actual work that's going on, but what messages are getting sent around, who's communicating with whom, what is going on between your various racks, and feed that into some sort of analysis subsystem that they were trying to build. And just as a technical segue, this is a moment where they were struggling to make, for example, Spark work. They had gotten Naiad, which is what we had done at MSR, up and working, but they're on Linux, and the C# support on Linux at the time was not stellar.
Yep.
So the guy in charge, Mothi Roscoe, basically said, "Look, why don't you just show up and help us sort this out, because this sounds like it's exactly what you've been claiming your stuff is good at, and we could really use it, and we can pay you, and you're in Europe, so like, and Switzerland's nice, so go for it." So that led to some recurring collaboration with them. So I worked there for about 7 months, and then.
So just so I understand, so you got Spark to work, or you got this thing from Microsoft to
Oh,
work?
I didn't get anything to work. Sorry, they were already trying to. They knew what they wanted to build, essentially, like sorts of analyses they wanted to do, and they had tried to do that with Spark. And Spark, unfortunately, at the time was just falling behind. It couldn't keep up with the data volumes.
I see.
The work from Microsoft Research, the stuff that led into this real-time streaming work, timely data flow, stuff like that, was originally at Microsoft this project called Naiad that was a C# project, and worked great on Windows and worked on Linux, but
How do you spell that?
oh no,
NYAD?
Naiad. And
Naiad. Okay,
it's
cool.
Greek. It's the naiads were the animating spirits of the rivers and streams and flowing water. And yeah,
Oh, that makes sense. There was a big data project called
yes,
Dryad.
yep, the same group of people. Yep.
Oh, interesting. Okay, so is Dryad like an evolution of
No,
Naiad, or
it's
is
the
it the other way
other way
around?
around. Though evolution is maybe a bit strong. So Dryad certainly came first. Dryad sort of came to be after MapReduce rose in popularity, and Dryad essentially said, why not think about larger data flow graphs, but still use roughly the same principle. So dryads are the animating spirits of sort of trees and forests,
Yep,
which
yep.
is where that came from, building sort of DAGs of data flow graphs. But it's still very much in the spirit of batch computation. So this data flow graph runs by looking at its inputs, which are probably very large data sets, turning on the bits of work nearest those data sets, running them to completion. They produce output data. You start up the next people.
Yeah, so I mean, maybe just to give a bit of context here, like people know about, let's say, it's a good example here, like MP3s, where you have to kind of encode something in an MP3, and so you wouldn't necessarily have some incremental MP3. Like most MP3s are, there's some sort of bookkeeping and some stuff built into the file, and it might be random access, but there's usually some kind of paging, so it's not totally random access. And so you end up with like this kind of big volume that's effectively immutable. If you want to mutate it, then you would run it through a process that produces another big volume that's slightly different. And so this is kind of the essence of MapReduce, or let's say batch processing. So you can take this, you can break it up based on how the data is chunked. So let's say the data is separated in chunks, such that you have 1,000 chunks. And at most you can have 1,000 machines. You're reading in a chunk, doing something to it, and then emitting another set of chunks. Now those chunks get shuffled. That's a shuffle part of MapReduce, and then the shuffled chunks end up in buckets, and then those buckets can be processed a second time. And the output of all of this is just another huge batch of data. Spark and other things are kind of built on the idea of MapReduce, and there's a lot of also cosmetic things built on MapReduce. Like there's Apache Crunch, which was kind of a something that sat on top of MapReduce and just made it more accessible. But one thing that's not really clear is how do you handle like a fire hose? Like if you have something that's a machine that's generating logs incrementally, 1 a second or something, well, then this idea kind of doesn't fit that paradigm. And that's where the real-time streaming is really important.
Yeah. And actually, your example of MP3s is pretty good. I don't want to pretend to know a great deal about how MP3s are encoded, but you could totally imagine, like we've been talking now for almost half an hour, and we could record all of that and plop it down in a file and then have someone pick that up and start the encoding process. But it's just as reasonable to imagine that as we've been producing data, someone could be picking that data up and start the process of transforming it and encoding it, so that by the time we're done, the computation is also pretty nearly done and ready to disseminate. Or, for example, if people were listening, they could, in near real time, be picking up the output of the encoding process, something more efficient than just the raw WAV file, and not have to wait for the entire session to be sort of recorded and then processed and then uploaded and all these things. So a lot of the streaming it's one of the things that's cool about streaming, I suppose, in a lot of cases, it's the same computation as these batch computations. It's just done staged slightly differently. So instead of doing all of that first work at once and waiting until you're done, you can start the first step, whatever that happens to be, and start producing partial results. And then whatever the second step is, that can also start working at the same time. And you just sort of keep things busy where they would otherwise be waiting. So otherwise, everyone's just waiting for that first hour of data to be finished before they can even start working. And rather than do that, no, just get everything going all at once. And it's a bit more bookkeeping for sure. But the nice thing, I think, is that potentially from the user's point of view, they don't need to think of new idioms necessarily. The system itself can just change its behavior, and it just is suddenly a bit more responsive than it was previously. You don't need to educate the user to tell them you must write a new program. So that's potentially really powerful if you can harness people's mental model for how do I approach working with big data and not have to change that to be some new, totally different way of working with data.
Yeah, it totally makes sense. I think that streaming from a functionality standpoint is like a superset, right? Because you can always stream in a batch of data. But then in terms of what you can do, I'm sure there's some limits. Like you don't have random access to the entire data set all the time. And so there's some things that you can't do with streaming. Or if you are going to do them, you have to accumulate some kind of bookkeeping versus just doing it in one shot. I think the closest I've come to data streaming is, or with the issues, let's say I can imagine coming up with data streaming is through Presto. So Presto is this SQL engine. It's not for real time, but it keeps everything in memory. And so because of that, it's really fast. But because of that, as soon as you run out of memory, it just gives up. And so, for example, if you wanted to, if you have a giant database, it doesn't even matter the size, and you want to just see how many times your name shows up in the database, Presto can do that because it can read as little as one row at a time, look for your name, and then just keep a count. But if you wanted to do something like generate a histogram of names, then, or maybe a better example is if you wanted to join the table to itself so that all of the rows for the same name were grouped together, well, then Presto has to keep the entire database in memory in some way, shape, or form to do that self-join, and most likely Presto will just blow up. And so, you kind of the same limitations there kind of apply here, where you don't want to be in a situation where you need the entire data set at one time.
Yeah, I mean, you're not wrong. One of the things I suppose that streaming does is start to expose some limitations. Essentially, you can, as you say, like if you can look at a batch computation just as a streaming computation, right? Of course, the process reading the data off of HDFS or off of your disk or whatever is not loading it atomically into memory. It's looking sequentially, or most likely at the data. So it's sort of streaming in off of your hardware. So it's a type of streaming computation already. But as soon as you give people streaming systems and tell them, ooh, low latency, something, they start to believe them. They start to use it, and they start to be surprised if their computer catches on fire when you do something like this.
Yeah, that makes sense. So Naiad. So we're starting to see how Materialize got materialized, right? So you were working with ETH on Naiad, you're helping them kind of with that. And did you kind of see a lot of the issues that led you to work, start Materialize?
A little bit. Not, I wouldn't say directly. No. Let's see. So I'm just going to roll back the clock just a little bit so that
Sure.
I avoid tripping myself up in the future. One of the things that happened
Okay.
as I departed Microsoft Research is that we were no longer meant to be affiliated with Microsoft. We were no longer, in particular, no longer working on the Naiad code base, and it felt like a good time to pick up a new programming language. So I pivoted over from C# to Rust at the time and started essentially doing a reboot of that project. So a different version of Naiad that was fixed some of the issues that we had the first time around, and almost certainly didn't quite get as far in all the dimensions, but started being what is now this timely data flow in Rust project, which is actually what I went to ETH with and worked with them on there.
Ah, cool.
I would say that at ETH, this is an academic setting, and you have a lot more liberties. So one of the big distinctions between academia and Materialize we'll get to, but in academia, you have a lot more liberty to just do what you want and what you need. So in a sense, what they were working on there, they were acting as sort of the consumer of the technology. So they could just build bespoke pieces of technology that would just work because they're, as a bunch of computer science PhD people, they're all empowered to just write a whole pile of new code and say like, great, works for us, ship it. And Materialize, by contrast, is very much the opposite. It's like we, the people building Materialize, have these skills, but the goal is to target people, users, who don't want to have to get an advanced education in streaming data flow infrastructure or anything like that. The goal is very much to take the ideas, the things that were learned along the way, essentially, and try to map them to concepts and idioms that a lot more people are already familiar with. In the case of Materialize, that's SQL, which is a language that doesn't say anything about streaming or any of that stuff, but does have sufficient concepts, things like joins and views and indexes and reductions, that you can allow people to express queries and ideas in that programming language and then transport them. We do the hard work to do this, but transport them to streaming infrastructure.
Oh, interesting. That makes a ton of sense. How there's that there's a lot to unpack there. So yeah, I guess since we're on that topic, how do you prevent people from doing things in SQL that would just cause a lot of heartburn, like trying to join a table to itself, for example?
Yeah, so we don't.
Okay.
I think that's sort of fair to say. Like it feels a little bit like databases back from the 90s or something like that, where you could, with a crappy query, take down your production database if you go and try to do something that's a cross join or something like that.
Yeah, that makes sense. But with the right window size, I don't know if that's in ANSI SQL or if it's only in Presto, but there's this whole, we have this thing where we do a self join, but the where clause is such that we can do it within a window. Like if we basically sort the database, although sorting, I think in streaming would also be a challenge, right? So some of these joins, I think, but I think the streaming doesn't have to do everything. It just has to do some of the things that need to be done in real time. And so it's a good complement to something like Presto or Spark.
Yeah. So for example, you brought up like one of the main pain points, to be honest, with SQL streaming, which is window functions in SQL. And for folks not familiar, window functions in SQL are roughly a way to write in SQL the equivalent of a for loop. It's just sort of, you can say, put these records together, and now attach to each record its ordinal position in this list, like 1, 2, 3, 4, 5, 6, 7, whatever. And you can write queries that are really problematic. Like you could say, do this and then get me all of the odd records out. And that's a query. You can write it. It's a little little mysterious, but you can totally write this, and it's very problematic if someone adds one record to the beginning of this list, right? Because all of the answers change, and not just slightly change. The entire set of data flip flops each time you add one new record, and just very problematic in terms of performance and resources for that query. And it's a good question. Should you work hard to prevent people from writing these queries? Should you let them write them and learn that the performance isn't good? Some of the queries are fine, right? If instead of saying, give me odd versus even records, you say just give me the top 5. It doesn't flip flop nearly as much. You can add one record, and the worst you can do is bump someone out of the top 5. But it's a great question, and really, this is the heart of what a lot of the big data problems out there have been. How do I figure out how to present an API to users that these are sort of like handles to scissors? Like how do you present handles that you can grab safely? You don't grab the cutting part of the scissors, you only grab the safe part. So it's a tool that you can pick up and only use safely. How do you do that? Like we know how to give people access to computers from EC2. You can just check them out, write whatever code you want, and cause the computers to be arbitrarily problematic. That's easy. Like we know how to give people access to computers. How do you give them gloves that they can wear to access the computers safely and effectively? And sometimes that means telling people no. That's sort of where the essence of a lot of these big data design questions are. Is like, how do you prevent people from I guess give them enough rope to be useful, but not so much that they can get themselves into trouble.
Yeah, that makes sense. I think that I think over time you build this kind of mental model of what kind of works well with what engine. It's like, for example, like sorting. Sorting is almost never a good idea in Presto, because as soon as you want to sort, then you never know if, as you said, a record's going to come that needs to belong in the first position. Like the very last record you look at could actually be the first record when it's sorted. And so the only way to sort is to hold everything in memory, right? So now with Spark, for example, sorting is not an issue because it spills to disk. And so Spark will basically, imagine you have a huge database you want to sort by one column. Spark will effectively, create a file for, let's say, each letter. So the A file, the B, it's kind of like what you would do if you were sorting a list of folders. Is you'd have an A group, a B group, a C group, so on and so forth, and then Spark could just sort the A group, and you don't have to do it by the first letter. You could even do it by the first 2 letters, 3 letters, and so you could always find a way to do it in Spark where it will be fast and efficient. And I think you hit the nail on the head that it's like very hard to kind of like encode that knowledge. It's almost kind of like, you could go to Home Depot and buy a saw. You can't really buy a saw that won't cut your thumb off. Like they haven't invented that yet, and they probably never will. And so it's really about how do you let people experience Materialize or Presto or Spark in a way where they make mistakes, but they don't kind of blow up the system or cut their thumb off, right?
Yep, no, you're absolutely right. One of the things that's a bit tricky with Materialize, I suppose, is that whereas folks have this expectation with a lot of big data tools that you might cut your thumb off, or that you should not randomly do things on your prod cluster, for example. The database community has, with their products, have gotten pretty solid about trying to bulletproof a lot of the tools there, so that you can't quite as easily catch your system on fire. If some person shows up, they have quotas in place, they have ways to protect queries from interfering in each other. So the expectations are a bit higher with that crowd, actually. So this is definitely one of the slightly awkward moments, is that the prospects are showing up are like, well, I expect to be able to have 20 people use this and not get in each other's way. What's your story? And we sort of have to come back with, well, our story is big data sort of side of the story, which is that if you really need these people to be isolated from each other, you should probably turn on a few separate copies of Materialize. And it's not as exciting an answer as they were hoping for sure, but it's realistic, at least at the moment.
Yeah, that makes sense. Yeah, I think the way we do it at my company is there's like a Presto quota, probably same thing for Spark. There's like quotas, and so if you maximize in theory, the worst case scenario is where you get as close as possible to once you exceed the quota, the job dies. So that's actually not that big a deal. But it's if you're right at the quota for a really long time, and if a bunch of people are doing that, then things can start to get really bogged down. But that should be super, super rare because no one. It's hard to really design something like you can't really optimize your query so that you're just under the quota. So
Yeah, no, I mean, you're totally right. And there's other, if people did, there's some clever things. You can totally randomize the quotas a little bit to make sure that any
oh yeah, just introduce white noise in the
just,
quota.
harmless, just plus or minus a little bit, enough that no one can actually sniff out where is that boundary
Yeah.
that I can safely operate on.
Yeah, that's funny. Okay, cool. So yeah, so we kind of actually one thing about Materialize, and we'll go back to the background. Is it ANSI SQL or have you added things to SQL?
Yeah, the target is ANSI SQL. We were very very cognizant of the fact that with SQL, the language, there's a bit of an uncanny valley where if you are in fact SQL compliant, great, people can use you, tools can use you. So a lot of people's tooling uses SQL. If you're only 90% SQL compatible, things catch on fire pretty quick, right? Right, like you can demo.
Yep.
Here's a join and a reduction. You're like, oh, that's great, join and reduction, pretty happy with that. But as soon as people realize that maybe you've got different semantics for nulls in some places, or maybe you don't do a great job at multi-way joins, or support prepared statements, or various things like this, your tools start to fall apart. Things that used to get correct answers suddenly get mysterious glitches in them. And although you thought 90% compatible, the actual usefulness of the SQL is closer to zero at that point. So we've cleaved very strongly to ANSI SQL. We have there's SQLite has a 5 million query test battery that we're in total compliance with at the moment. All sorts of really
cool.
obscene cases, like things that you wouldn't. I would never have thought someone would write these queries. You can write correlated subqueries in the join condition of a outer join, and it was some pain to get those to be correct and correct in a streaming fashion. But it makes a lot of sense. Like it's very sensible to try to do SQL right if you're going to do it. We've not really added too much. There are a few, I would say, interesting interpretations that we've done of things. They're a bit technical. I'm happy to go into them, but there are things that don't really make quite as much sense in a standard database, but have really cool interpretations in the streaming space.
Yeah, I mean, what's an example of something of one of those things?
Yeah, so like one of the things that in a standard SQL database, you can use. I'm going to lie a little bit here, but you can use the now function to get the current time for when your query is being run, which I don't know, you might do to print out along with your results when did a thing actually happen, something like that, and that's fine. That's a good use of now. You can do something really interesting though in Materialize, which is to put that now term in a predicate, like in a where clause. So you can say like where my data dot timestamp greater than now, and what that does is holds back the data until the current time is equal to whatever value is seen in your data. Right. So since we're evolving the results of this query over time, it's going to give essentially a temporal instruction to the system that says, here's an interesting record. Don't show it to anyone until the time that is written down in this piece of data. And it allows you to start programming with time and stuff like that in a way that, you could write that query in vanilla SQL that just does one-off queries and gives you the answer. But it introduces some really interesting new behavior in a streaming system that is going to update the data over time.
Yeah, that's wild. I mean, as soon as you introduce something like that, then you can't really throw any data out because you just don't know when it could become relevant, right?
Yeah, though delightfully, right? You can use this exact same query to say where my data.timestamp, I think it's less than now. What the other direction, the other inequality direction?
Yeah, sure.
Eventually says like throw my data away as soon as this time passes, right?
Oh, that makes sense.
This record will never pass this predicate again because we know that now only goes up, and you had some piece of data that we've now passed. So this is actually a way to give in your query to describe what data are okay to garbage collect and clean up, so that you can keep if you wanted to have, for example, a 1 hour window that you're maintaining that slides continually through time, you could totally say, blah, blah, select all the records where now between my data .timestamp and my data .timestamp plus 1 hour. And that will wait until that time to introduce the data, and 1 hour later clean up the record, throw it away. You'll have a constant memory footprint over time. And just stuff like that, again, if you're thinking about, no, I'm just going to use real data, like a data warehouse, you got to plop all your data in there, and it's got to look at all your data over and over again, because who knows what's going on in there. By giving clearer instructions to the stream processor, we actually can learn a bit more about what do you really need to keep around, like what data can we throw away, and how can we more efficiently operate to keep your query up to date.
Yeah, that makes sense. So what about, one of the things that I was really excited to see Spark 3.0 add is the sort of array aggregation and all of that. So like you can, for example, there's an array column type, which is in in Hive and SQL, but not in ANSI SQL. And that array data type ends up being super, super useful. Like you might say, take all the records with this person's name and build an array of I don't know, all the ages the person said they were, and then let's analyze that distribution or something. And so that seems to be the thing that I miss the most whenever I'm using something like SQLite. I always kind of miss, array ag and map ag and some of these functions.
Yeah, we have several of these. I don't want to. I get myself tied up a little bit when I try to distinguish all of them. There's arrays and there are lists, and there's a little bit of a difference because Postgres has. We're basically following a lot of Postgres. There's some distinctions between the raggedness of arrays versus multidimensional arrays, and it hurts my head to try to keep all of these straight. But yeah, there's. I'm thinking of what we have literally at the moment, and we literally have a JSON-B aggregation that allows you to do these groupings and then pack them into a common JSON object. If we don't have an array aggregation, it seems like the sort of thing that's super easy to add. But yeah, the functionality, I guess we've generalized it a little bit. I think we've not invented too many things of our own. I want to be careful, but we have. When you look at what folks come to us with, like they show up with Avro data, and Avro, can represent some quirky things in it, and we got to figure out like, well, someone showed up with some Avro data. We need to make sure that the type system is rich enough to reveal the various things that people might have shown up with for data, and that includes various forms of arrays and stuff like that aren't as commonly seen in ANSI SQL.
Yeah, that makes sense. Okay, so we got to ETH Zurich. We went back a little bit to talk about Naiad, and so yeah, let's sort of continue the story there. I mean, was Materialize created while you were on this road trip, or was it like conceptualized while you were on this road trip?
So I think the right way to frame it is that Materialize was conceptualized by my co-founder Arjun Narayan, who was working at Cockroach Labs at the time, and he had during the course of his PhD been working in the same sort of area, big data systems, stuff like that, and had.
Yeah, correct me if I'm wrong, but Cockroach DB is like a key value store, right? Like a big data key value store.
Yeah, roughly. I mean, it's more of a transaction processing, like OLTP style system than an analytic processor. And this makes a bit of sense, to be honest. Like they were, I would say, I'm not an expert here, but they were good at what they were doing, which is storing data, keeping data, consistent, all these sorts of things. And we're sniffing around for like, well, what's the right way to process all this data, right? It's sort of silly to do all this and dump it out to HDFS and call into Spark or something like that. And Arjun's take, at least, I hope I'm not misrepresenting, was that the Naiad paper, the thing that came out of Microsoft Research, was a great answer to all of this. Right? It sort of resolved a lot of the quirks that stream processing systems had at the time, and that this would make a lot of sense for anyone who uses a transaction processor to keep the primary source of truth for their data, but wants to attach to it some analytics that will continually be able to ask questions and also keep answers up to date for questions you've already asked. So I would say he and potentially collaborators at Cockroach, but he was the one who was pushing forward on the idea that this is really interesting technology, and there's actually a pain point that people have out there where you can use a data warehouse for sure and just ask questions over and over again, but there are a lot of people who have relatively fewer questions, I suppose. They want to see the answers to their queries refreshed as quickly as possible, always up to date. And ideally, this shouldn't have to mean that you have to go back to the data warehouse once a second and reissue the query from scratch. So he was the one who sort of showed up, I would say, with the like, let's actually do something specific here. His pitch to me was roughly like, we knew each other from before, but his pitch with respect to the company was, it's super interesting, like all the stuff in Rust that you're building, and you write a bunch of fun blog posts. But if you actually want to see if this has legs, if this can actually go anywhere, there are going to be annoying things that you don't want to have to do. Someone's got to write documentation. People are going to have to do write tests. People are going to have to go and shake hands with potential customers and stuff like that. And that's not what you want to do in your day to day. And you're totally right. But the right vehicle to do this was to put together a company, basically put together something that has some funding so that you can pay people to put together marketing information, to put together documentation websites, write tests, write SQL compatibility layers, stuff like that.
Yeah, this touches on a really, really good point. I think there is this kind of misconception that a startup company is, like Steve Jobs and Steve Wozniak in their garage, just writing, building a bunch of systems, or just one person in their garage. But you're totally right that you need to have sort of sales, you need to have people writing documentation, you need to have that whole ecosystem right at the beginning, and yeah, and I see a lot of people who have some really good technology, but I think they kind of miss that part of it, that you need to have that whole part of it. And we talked a little bit about this in the last episode about Docker, and I don't want to beat up on Docker again, but your Docker has amazing technology, but then on the business side, there were some real challenges. And so it's really important to kind of have a person who's really plugged into that, who can help out with all of that.
I definitely found this to be the case. I imagine in most startups, these roles exist, whether you like them or not. Of course, someone to do community management or tech support or these things. And presumably in most very small startups, everyone just wears 5 different hats. And you probably do a little less good of a job than if you got in a specialist to do a thing. And so part of what was compelling, I suppose, about Arjun's proposal is like, this is good enough stuff that we can get some funding and actually get people who are good at these jobs and like doing them, rather than have to slog through the unpleasantness of doing them ourselves necessarily.
Yeah, makes sense. And so did you go straight from ETH to Materialize, or was there something in between?
Oh, yeah. Sorry, there's a bunch of time dilation that went on. And I was at
Okay.
ETH twice, actually. I was there for 7 months the first time, and having done the thing that I thought I was there to do, went off and tootled around a bit more in Europe. It just happened to be where I was, and did some more surfing and just relaxing. And eventually ended up going back to ETH for a little over a year, and was a bit more formally there at the time. I was working with students, advising folks, sort of helping some folks see through their PhD dissertations. But then it became clear that that was not for me forever, and that Materialize made sort of a lot more sense. And the second time there was departed, I would say, it's early 2019 roughly, and landed in the US. And at that point, Materialize had already been started up, essentially. Arjun and I had chatted about it beforehand and thrown some decks around. But yeah, I came back from Switzerland and was employee, I think, number 5, I guess, at Materialize at that point.
Cool. So what was it like to talk to investors? I mean, that's so I also have an academic background, and since going to university, I've really only worked in research labs, and so you kind of share that background, at least up to ETH. And so what was it like going from that to creating a pitch deck, talking to investors, and what was that transition like?
It was, for me at least, it was very surprising. The thing that was surprising is I think we went through about a week of pitching stuff in the Valley, and each meeting that we went into, I went in with some preconceptions and came out with exactly the opposite conclusion, basically, about what I had expected. And
like what's an example of that?
No, I mean, just like we went in, I don't know, the very first thing we went into, we were like, oh, this is great. We're pretty solid. The deck looks pretty good, and came out of that, and there's a lot more skepticism about things than we had realized. Not of the type, like, no one doubted the technology or anything like that. They were like less sure about how big the market was, for example. I'm like, geez, I hadn't even thought of that.
Oh, that makes sense.
We went into the second meeting, and I was pretty sure that ahead of time, the person that we were going to chat was already invested in what was essentially a competitor, and we were basically thinking like, oh, I guess we're in deep trouble, and like this isn't going to work out. We can just sort of warn them and go home, and they're immediately like, no, I'm interested. I'm very interested.
Were you afraid of even giving the pitch? Because if they're already invested in your competitor.
Not really. I mean, I think one of the nice things about Materialize that's very reassuring is that nothing we're doing is secret. So it's not that there's some cunning information that if anyone got access to it, they would suddenly have a big advantage over us. The main advantage that we have is the technology that we're using is pretty cutting edge, I would say. I mean, that's self-serving, but
yeah, makes sense.
That's the main thing that distinguishes us. And it's not trivial for anyone else to say like, oh, I see, we should just use the same technology and we'll be where they are. So we weren't too worried, at least I wasn't too worried about showing up and saying, hey, we're going to do a thing. This is the thing we're going to do. Keep it a secret. Like, I don't think anything that we were talking about was particularly secretive. So no, I wasn't too worried about that. Maybe I should have been. I don't know. I'm hopelessly naive when it comes to some of these things.
No, I mean, I think what you said really resonates. I mean, I think to replicate it, they have to really replicate your whole history. It's not good enough just to take a snapshot of what you're thinking right now. You have to. It's not Markovian, right? Like it's kind of based on your trajectory is kind of based on all of your experiences, and you can't easily transfer that.
No, it's totally true. So for example, one of the things that we've had to do and has been like some of the value that's been added at Materialize is trying to figure out how to take a bunch of these crazy SQL idioms and map them down to data flow computation. So when someone has a correlated subquery, someone's got to figure out how to turn that into data flow computation, and that's not explained anywhere else, right? That's not a thing that exists in the open source software that I had previously written. So it was very much a bet on the team will be able to figure this out was the bet that the VCs were making. Not that the software already does it, but that there will be some problems they'll be faced, but these people are well prepared to clear those hurdles, essentially.
That makes sense. And so this investor was super interested, and then did you kind of what was that conversation like? Where you at some point you had to kind of talk about the elephant in the room, right? Which is that they're kind of double dipping.
Oh yeah, they were very candid. Yeah, they were very clear, and it was that their responsibility, like they have some responsibility, of course, to the people that they're invested in, but they also have responsibility to the people who've invested in their funds. And as long as they're not in conflict, I think this person's particular take was like, as long as it's not zero sum, right? If all the money that you would make would come at the expense of these other people, that's no good. Like that's not a thing that they can in good faith do. But if investing in two people who happen to be sharing a pie, in the course of that, the pie is actually let's say 50% bigger than it initially was, then okay, company one doesn't get all the money in the world. Companies 1 and 2 have to share it, but it's in this case much better for their the investors in the fund that the VC is managing. I have to imagine also that there's different takes on this, right? That across the spectrum of VCs, some people are perhaps a bit more kind and gentle, maybe, and some people are more vicious and trying to get access to whatever money is that they can get. I have no idea. I definitely don't want to judge there. But
yeah, totally. I mean, this is just one meeting, but I think it's an interesting kind of dichotomy, because on one side, I think you hit the nail on the head. It really depends on, is the pie growing? So if there's 1,000 customers and the startups are only able to sort of acquire one at a time, then and that there's a whole ecosystem full of startups out there, then I mean, it totally makes sense to have at least 2 of them, maybe even more. When things get big and it becomes like an Uber Lyft type thing, there's actually this podcast that I follow called Business Wars that talks about when companies get so big that they basically exhaust the market and then they go to war with each other. It's a fascinating podcast, but I think that is maybe if Materialize is like competing with the next biggest player, and both companies are dominating the world together, then that's not a bad position to be in if you're an investor. It's like, okay, I'll take that.
No, you're not wrong. And each of the participants, Materialize and the other person would really love that if the other person would sort of not be there, or their lives would be a lot easier. But from the investor's point of view, presumably, no, this is great. Like both of you are going to make better products. Both of you are going to compete to be price competitive. I'm sorry, I'm making up a bunch of economic stuff. I have no actual background here, but I can imagine a world where it's not inappropriate to support folks who are again eating more of the pie as opposed to trying to fight over the same piece of pie.
Yeah, totally. So okay, you start up Materialize. You're employee number 5, and you have this sort of academic background. I'm assuming there are a mixture of people who are really into the theory and handling a lot of these edge cases and doing a lot of this really complex transformation of SQL to your engine. Then there are a lot of, I guess, front end engineers, and there's a whole engineering area. How do those two areas kind of collaborate?
It's a great question. I think the short version is that the folks who are really interested in the theory, like the me type people, needed to adapt a little bit. And this is mostly because when you look at it, what Materialize actually needs to do, the goal isn't specifically to advance some very cunning theory and to be really smart and write obnoxious blog posts. It's actually to do a specific thing. Right. And if you look at, if the folks, generally speaking, the engineering side of the house of Materialize is a bit more eyes on the prize about we need to actually make this work. That's the actual goal. The goal is, okay, the friends made along the way. It's also very good. But the reason that we're here is to try to put together a thing that looks and behaves a lot like an escapes Postgres, complies with SQL, and under the covers does it all very efficiently, hopefully, things like that. And that's actually the goal. So, folks should, in some sense, should get in line and do that sort of work. And I remember when I showed up, I was initially very like, oh, this is exhausting. SQL has so many warts. It's gross in a few different ways. Do we have to do this? And at the time, I was like, oh, maybe. I was thinking maybe we don't. We could do some funny business somewhere. And the answer is pretty clear. No. Like it's really important to do SQL correctly. That may suck. I'm sorry, but the thing that we're making makes sense if we do SQL correctly and not otherwise. So let's figure out how to do that.
Yeah, I mean, speaking from the other side of the table, there is something that wasn't ANSI SQL. I'm trying to remember. I think it was maybe like Hive. Yeah, Hive. So Hive isn't ANSI SQL, and so just converting queries from Presto to Hive, or from testing them locally on SQLite and converting them to Hive. Like it's never a straight conversion. It's always a huge pain. And you're always kind of wondering, like, why didn't they just take the extra step? Now, I mean, Hive, I think that whole Hadoop ecosystem was filling such a huge void that they had a lot of latitude in terms of the product. But ultimately, I mean, Hive was replaced by Presto and Spark and things that were more compliant. So I mean, even then, I mean, it didn't last. It was just a honeymoon phase, right? But yeah, you hit the nail on the head. I mean, if especially if you're at a bigger company, if you have 20,000 queries that you run and you push them to Materialize and like 100 of them fail, for one person who's trying out a new product, that's insurmountable to try to fix 100 queries. And it's usually really ugly fixes 100 times, and so it kind of can't be 99% done. It has to be 100% for you to really get those customers.
Yeah, that's absolutely correct. And again, one of the changes, I guess, coming from the academic space is like in the academic world, it's a bit introspective there. You're like, my goal is to think of a clever thing and then tell the world about it. Whereas in the business, the sort of real world side of the things, your goal is to meet the potential users where they are, right? Like you want to get some technology to them that they can pick up immediately and start working with. And they're more and more delighted the less they have to screw around with it or figure out, or, if their life is now fixing these 100 queries as people write new ones. That's terrible. I mean, that's not the thing that they were hoping it was going to be. And you get to notice this a bit more as you show up. And I mean, I was learning this, at least coming from academia, where you get rewarded for being clever and different, to a space where absolutely the goal is to try to be as not different as possible. Ideally, not have to tell anyone about your cleverness. They just sort of experience that your product is, for whatever reason, much more pleasant to use than the competition.
Yeah, that makes sense. And so in terms of customer acquisition, is Materialize's style kind of like a bottom up thing where you have a free tier and you try and get developers to convince their manager or director to jump on board, or is it more of like an enterprise thing where you go and make a pitch to the leadership? Like what's the kind of model for Materialize?
It's a good question. I probably gonna script the answer to this because they're very like sort of clear takes on each of these things. My experience with Materialize has been that the people that we end up trying to convince Materialize is good have so far been not strictly the bottom up, like just random developer trying to get a thing done, but maybe like a tier up from that. So a person who's trying to think about like, how should I organize infrastructure for my group or something like that, or like I need to support a few people, various people writing SQL queries. How should I go about doing that? And this person has some latitude to make a good decision or bad decision, but they're decision-making type of person rather than a person who can pull whatever they want onto their laptop and start using it. At the same time, we're not sort of going over and scheduling meetings with Coca-Cola to try to tell them like, please stop using big competition and start using us instead. Business, handshakes, martinis. I would say the motion is a bit more bottom up in the sense that it's technology led. Folks are meant to understand, the users are meant to understand that this is a valuable thing to do, that they like the experience more, low latency responses to queries are better, as opposed to a more top down, like your organization will be better, cheaper, whatever, if you pivot over to Materialize. That might also be true, but it's harder to put that in front of people at the moment.
Yeah, I think anything having to do with data, anything having to do with data will require you to be a step up from the developer, because it's not something you can run on the cloud. Like people aren't going to just move all their data to some kind of public cloud that Materialize has access to. And so something has to be, I'm assuming something has to be kind of done where Materialize is kind of plugged into whatever, their data system. I mean, it might be on AWS, but it's obviously not going to be something that's exposed to the public.
Yeah. Though I should say, to take this opportunity to throw out there that Materialize Cloud has just entered private beta. Folks go
nice.
materialize.com/cloud and hop onto the sign up list. There were, folks are being admitted in waves, but the intent is for sure to try to put together a thing where an organization can try this out. We'll deploy inside your private cloud in AWS. But if you've got your data in Kafka or something like that, we can attach a Materialize instance to it and start reading it and give you, like 30 seconds or something like that, interactive experience where you get to see what it's like to start use this, maybe start to make some decisions about, is this, you loving this, or is it the same problems as before?
Yeah, that makes sense. But insofar as like it is kind of a bigger commitment than trying out a different ID, for example. And so insofar as that's true, like I would say from what you described, Materialize is sort of bottom up at the lowest level that you can reach and still get the kind of commitment that you need to set up.
You're right that it's more sophisticated than just getting a new IDE or a new theme for VS Code or something like this, for sure. We've tried to make it not terrible from the point of view of an incremental deployment. So for example, step one is not reformat all of your data into our native representation or something like that. Like we'll look at your Kafka topics, pull data out of there that could be CSV formatted, could be Avro or JSON, various things. Hopefully the ways you've already written your data down, so that we're not actually introducing any new costs for you. So it's not as bad. Like for sure, other systems out there, step one is okay. We need to pivot all of your data in HDFS into a columnar representation because that's the only way we work efficiently. So like 1 week later, you can actually try running one of these.
Yeah, exactly.
Sort of grindy, OLAP style analytics tools.
That makes sense. So you're kind of plugged into Kafka, and I think the Amazon is like, I want to say it's Kinesis.
Kinesis is another one that they have. Yeah.
Yeah, there's a bunch of these pub sub type things, or basically sources. We'll say sources for real time data, and so you've written kind of adapters for a lot of these different sources. And so as long as people are using one of these, kind of standard things, then they can try out Materialize.
Yeah, and the goal for sure is to show up from our part, show up with as many of these points of integration as we can reasonably manage with the team that we have. So, if you can pull data, Kafka is the easy one at the moment. Kinesis has some interesting characteristics that make it a bit harder to show people the data and be correct and like show them the same data again a second time if it crashes and starts up again. But for example, also there's some recent work to pull data out of Postgres as a read replica, essentially. So to use the replication protocol out of just a Postgres instance and say, like, if you have your data in Postgres, Materialize can attach to that.
Oh, that makes sense. Yeah. So stepping back a bit, looking at, someone who's in high school or college and maybe they have some very, very limited SQL, like maybe they've written they've made some MySQL queries on a startup, a small project, a hobby project. How can they get started with Materialize, and is there sort of a free tier, or what's a way for students and hobbyists to learn more?
Oh, absolutely. I mean, you can definitely Materialize is source available and very nearly as available as we can make it. It's BSL licensed, so basically anyone can go and grab it, and as long as you aren't building a competing database as a service style product, you're free to use it for whatever you want. And you can
Cool.
go grab the code, build it. We have Docker images that we should push out each time we successfully build something. And you can just grab this down, pull it down to your laptop. You don't need any complicated Apache infrastructure. You don't need Zookeeper up and running, any of that stuff. It's literally a single binary. You turn it on, you connect to it as if it were Postgres. So if you have a terminal and you use pSQL, which is sort of standard way to shell into Postgres, you can use that to connect to Materialize. And if you don't have Kafka up and running, you can point it at a file, for example, and you can append rows of let's say text, a bunch of different formats, but append rows of text to the file and see the results continue to update there. This is one of the sorts of interop that, it's a little janky, but this is how folks have prototypes on things where you have a file on your laptop that's continually scraping some other source of data on the internet, appending stuff to the file, and then Materialize is essentially tailing that file, right? It's watching for changes to it, and anytime new data show up, it'll push them into the pipeline and update all of your queries. And you can do all of this without
Very
complicated
cool.
enterprise infrastructure or anything. It's just on your laptop. This is how I use Materialize a lot, to be totally honest.
Oh, that makes sense. It's kind of like you could use it as kind of like a tail on steroids.
No, absolutely. Like if you're used to using, I don't know, like awk or something like that to do a little bit of data munging through your CSVs and needed something more advanced than that. Like awk is great at what it does. I use awk a lot. But if you're like, geez, I really need to take these 5 CSVs and find things present in here and not present in there, get the distinct these things back out, yada, 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 something SQL-like. You can totally use Materialize to do that and keep things up to date as data change if that's exciting to you.
That is really, really cool. Yeah, that is really. Let me just give a bit of tech background, and feel free to kind of correct any records here, because this is just shooting from the hip here. But so a bit of background. So there's in Unix there's tail, so you can have a big text file. You do tail file, you get the last 10 lines, right? Simple enough. There's also tail-f. If you do tail-f, instead of just giving you the last 10 lines, it will actually just listen to that file just forever. And anytime a line is appended to that file, tail will print it out. So think of tail-f as like this monitor that's just listening for changes and writing them out. There's also a bunch of other Unix commands, like there's awk and there's sed and there's jq. All of these are ways of extracting data. So if your file is rows of JSON objects, so every line in your file is a JSON object, you could pipe that over to JQ, and you could pull out one of the entries, one of the keys in that object, right? If your file is rows of text and maybe there's a timestamp you're interested in, you can use tr and sed and awk, these other tools, to pull out that timestamp. But then, as soon as things start to get complicated, like maybe you need to keep a rolling histogram or something like that, you're really kind of stuck. I mean, at that point, you could try doing something with Python. At that point, you're basically writing a Python program that reads from standard in, and as soon as you jump into Python, you're writing a lot of code and et cetera, et cetera. So SQL would be really attractive. There's a lot of times where I've converted things to, or I've just loaded things into a SQLite database just so I can run queries. And it takes a long time. You have to transform the data, especially if it's just flat text. And so Materialize, running it locally is a really, really attractive alternative. You could have a Materialize that's tailing, CSV, or I think it's called JSON-L, where there's a JSON object per line, a JSON-L format, and do more complicated things like groups and windows and all of that, without having to,
That sounds absolutely correct. I realize I say tail a lot, and we say tail a lot inside Materialize, but tail-f is actually, you're right, absolutely the exact specific use of tail that we should be thinking of. Where
Yeah, I mean, there's tail the verb, and then there's tail the command, right? I think, tail the command is just this one-shot thing.
But I think you're totally right that there. One of the things we've seen a lot of interest from folks about are not even necessarily big data, anything in particular. Those folks are interested, of course, but there are other folks who are just putting together, like, even let's just call them web apps or something like that. Things, that I suppose at the moment they would be using something like Firebase to get told about changes to their data, but in fairly primitive elemental ways. Like maybe they pass a filter and you get to see records that pass the filter, and that might then prompt them to redraw a web page or do some work like that. And Materialize is pretty appealing in that you get to have the same experience, except you push a more interesting query through to the server, essentially. And you could say that this is wonderful, but just only show me when a particular more complicated property happens. Show me when new distinct users show up, or someone logs in after 5 minutes later than they had ever previously logged in. Things like this that these people don't necessarily have terabytes of data to work on, but it's really handy to have someone save them the pain of writing either, the Python or the JavaScript or the whatever it is that is handwritten bespoke code to try to put together a thing that does the not necessarily very complicated task of figuring out when should I tell someone that a new thing has happened. And Materialize is, sort of popular in that space, at least as an idea. Like, why can't we have this for other classes of programming? Essentially, SQL and big data is great, but there's lots of other people who deal with reactive applications. Essentially, they're trying to build whatever, literally React style web pages that you want to express what it should look like. The data might change. Why can't the computer system take care of all of this for me? So, like, the bug, I think, is getting out there in terms of people expecting, even wanting, but eventually expecting that their system can actually take care of all of these updates for them. They don't have to handwrite a whole bunch of triggers and weird callbacks and stuff like that.
Yeah, that makes a ton of sense. I mean, I think one of the biggest, challenges, or biggest, say, like mistakes that people make when they're starting out is using a programming language, or maybe another way of saying is using something like Python or C++ instead of using Unix commands and SQL. I think that I know when I was going to college, I kind of thought, oh well, SQL, that's for people with real jobs.
Yep.
Like I'm a PhD student, if I needed to read one column out of a CSV, I would just start int main and writing C++, and that made me extremely unproductive. And I think that is it's a lesson that's super, super important, and having the ability to do real time. I think there's a massive tail of folks who could make really, really good use of something like that just don't know about
this
it.
There's a computer science principle, actually, that gives name to this thing called Oosterhout's dichotomy, where this is, I think, John Oosterhout at Stanford, who proposed essentially this roughly two types of programming languages. Right? There's sort of this productivity level language that's a bit like, I don't know, awk would be a good example, or SQL. You can use it to get your job done as quickly as possible. And then these more systems-y programming languages, let's call them like C++ or something, which is, let's say you want to build one of these tools, right? Like someone actually has to build the things. And if you know one of each of these languages, that's pretty good, right? Like only knowing a productivity language or a systems language, you're going to have some limitations, either because you only know C++ and you spend all of your days trying to open files and read lines and stuff like that. Or if you only know SQL, it's a little hard to invent a new thing, essentially. If SQL isn't doing what you want, you're kind of in trouble at that point and need to get someone else to help you. But if you know one of each of these things and can move between them, that's a really good place to be.
Yeah, that makes a ton of sense. Cool. Yeah, I think Yeah, this is amazing. So folks out there, we should definitely, I'll give it a shot. I think folks out there should definitely grab Materialize. So I know there's Docker. Docker's usually pretty heavyweight, but are there like just standalone, like statically compiled binaries for different
Yeah,
OSs?
we've hopefully I'm not screwing this up, but I think we have them. We have like a apt-get repo. There's, I believe, we have it at times. I should make sure it's up to date, but homebrew versions of these things. You just grab the code and build it from source if you're that sort of person. I should double check all of the package managers we have, though. I think there's a few that we for sure keep up to date, and some that we might have either let slip or lost some traction with.
Yeah, I mean, as someone who I have a package in a bunch of these package managers, and it's so difficult. I mean, I'm currently right now I have an issue on Ubuntu 18, but it works on all the other Ubuntus and 10 different other OSs. And so it just like it like never ends. Like there's always like something that breaks
Yeah.
somewhere.
It's
And
a real job keeping
I
that up
think
to date. Yeah.
one of these days, someone needs to write some way to automate that. But that's going to be a challenge because they're all so different.
I mean, I'm sure someone has written that thing, but it's only supported on some of the OSs, so you can only use it in some stuff. I mean, it's one of these, like the XKCD cartoon about like there are 14 competing standards. We should invent a new one that encapsulates all of them. And now there's 15.
And now there's 15. Yeah. Yeah, it's so true. Yeah, I guess that thing is probably Snapcraft, which which doesn't have enough market penetration. Like I don't think they cover Windows. And so yeah, you're right. You can't really, I mean, maybe you could lower your number of things, but you can't get it down to one. Cool. So let's jump into Materialize as a company. So what is a day like for a scientist or an engineer in Materialize? Like how, specifically like how is it, everyone kind of, or I guess pre-COVID, let's say everyone drove into work, had a cubicle or has a bullpen. But is there something kind of unique about life at Materialize?
Well, we're in New York City, so no one drove anywhere. You would
Okay, well there you go.
hop into your metal cylinder and be propelled, from one end of the city to the other. But yeah, no, it was. It's changed. I guess it's part of the problem. So I'm trying to get a snappy way to characterize it. But early days, it was we're all basically within 10 feet of each other, and there's a bunch of rapid prototyping and sort of turnover where like I'd put together some code and then hand it over to someone else, and they'd come back and say like, oh, this doesn't, this isn't correct from seeing. Okay, well, let's iterate on it. There was a lot of dynamic energy where things were randomly changing and we were trying stuff out. As we've gotten bigger, this has cooled down a little bit in that people go crazy if you just randomly change what they're working on while they're working on it. So we have, I mean, sorry, this is not unique to Materialize, but a process now of like sort of
No, it
clear
makes
goal
a lot of
setting,
sense.
stuff like that, trying to figure out for example, in turning on the cloud product, what are the steps we still need to do before we're comfortable putting that in front of people? Folks have nicely carved up bits of work where we're pretty comfortable. I mean, if the work gets done, it doesn't necessarily matter how it gets done. You don't need to be sort of butt in seat for any particular hours of the day or anything like that. Depends a little. Like, the cadence changes a little bit. Sometimes something new and exciting gets put out there, and it's worth having you sit around for a little while to see did anything catch on fire or help out people who don't understand exactly what you did. But generally speaking,
That makes sense. What's the coolest offsite that you folks have done?
well, so we haven't done too. We've got a few, and I'll name my favorite one, but we haven't done too many because it's just about a year, and then COVID happened. So
Oh yeah, that's right. It's not too
and
much
there's
time.
not any offsites since then. We desperately want to do one, but we've done two. Basically, we went to upstate New York and did some hiking. This is when we were about 5 or 6 people, and I don't know. It's, I would say fairly stereotypical, but super fun. Like hiking during the day, and then Smash Brothers at night, and some name
Nice,
calling
awesome.
and some whiskey and stuff like that. But it was just totally appropriate for who we were and what we wanted to do at the time. Some folks went rock climbing. Like everyone's just happy to get out of the city and just sort of stretch their legs in the outdoors, and that was great. And then I think it was February actually, before anything got especially weird. We went on essentially a skiing trip, though it was up in Vermont and it was raining rather than snowing. And, it was just mostly getting some time out of the standard work environment where you still get to be social with your colleagues. You get to, it reinforces the fact that these are actual humans, not just people who write annoying comments on your PR or something like that. And just chill with people,
makes sense.
spend some time socializing that doesn't have to be in a bar drinking or something like that. It can just be pretty mellow, taking walks or just over dinner.
Yeah, that's awesome. Yeah, I think I think with COVID, it's a challenge. I mean, most of our, I guess, quote unquote offsites have been just playing video games. We just take some time out and play some games together, play a bit of Counter-Strike or something.
It's a little complicated because during COVID, I would love to do this, have like a virtual offsite, though it feels like a very weird thing to require of people. Like it's one thing to say like we're all getting in a car and we're going somewhere awesome, in which basically like, okay, fair enough. But if you tell them like we're all taking next week and we're not going anywhere interesting, but you got to log on and play some video games or something like that, and a lot of the folks are like, well, yeah, they'd rather do something else, to be totally honest. And it's hard to I mean, on the one hand, you'd love to take some time off of work to get people a bit more social and interactive, but it's a bit hard to tell them like your time, which is scarce at this moment, needs to be spent screwing around with us playing categories online or something like that.
Yeah, it is super awkward. I think it's a real challenge. And yeah, it's a fine line you have to walk between, if you make it kind of, let's say, or if you don't hype it up and promote it, then people won't show up. But then if you make it mandatory, then it kind of feels like you're in the show The Office, right?
Yeah.
So there's some fine line there.
So we had a holiday party, for example, which was done virtually, and straddled this line pretty well, I guess. Like, it wasn't strictly speaking mandatory, but everyone was definitely encouraged to come, and folks leaned into that and, got dressed up and made their own fairly nice dinners and showed them off on Zoom and stuff like this. And this felt pretty good. Like, it felt good that it wasn't, a now mandatory sit and look in a camera and have dinner together, which is not nearly as exciting as, we're all going to go out and have some cocktails and then a nice dinner.
Yeah, one thing, my team hasn't done this, but another team, I think it was like HelloFresh. Yeah, there's this thing called HelloFresh where they'll deliver ingredients to cook a meal, and it's just enough ingredients to make a very specific meal. And so they delivered this to everyone's house on the same day, and then everyone set up their portal device or their phone on a stand or something like that, and we all they all just kind of cooked together. I thought that was really clever.
I like the idea a lot, though. I got to say, like, the same sort of problems creep up, especially if there are folks in New York who some folks there, at least, kitchens are not the centerpiece of the apartment, and if you tell them like, unfortunately, you're gonna have to cook your own dinner tonight, no ordering in.
Yeah, that's a good point.
It's in the interest of the company that you cook your own dinner and eat what you make. It almost sounds like punishment. I think it's really fun. I like cooking, but
I never thought about that. Yeah, I mean, I also really love cooking. It kind of shows how we all kind of like bring our own biases, right? Like, I never would have thought that, but when you put it in that perspective, it totally makes sense, right? I bet there's some people who were just like what what I don't like my kitchen is just like this stack of boxes.
Yeah, I mean, same thing. Our first offsite was this hiking stuff in upstate New York, and I loved it. I think I love being out in the woods and running around and stuff like that. But I could totally imagine there's some other folks who are like, why this is not what I thought of when I thought it was fun. I was thinking we were gonna sit in a chair and drink some beer or something. And it's different structure, different folks, I suppose. But like this, I suppose again, this is one of these things that there's an art to doing it, and it's not necessarily a thing that's super easy to fake. So I'm impressed when people do it well. Of how do we bring together a bunch of people who have different goals, different ideas of fun, and nonetheless get them to connect. Yeah, when you can do that, that's great.
Yeah, that makes sense. So, are you folks hiring like either interns or full time or anything?
Oh, totally. Like that? Yeah. No, anyone who's interested should reach out. I think generally the answer is yes. Like, if you have a particular affinity for this sort of thing, we're interested for sure in interns. All across the spectrum of engineering background. There's not, I don't think, any particular thing where we said like, no, we just need to stop hiring this, that, or the other thing.
That makes sense. And so post COVID, the office is in New York City, and so people should if people are interested, that's one of the things they should expect that they would head over to.
We have actually several locations now, and we have people. Sorry, several locations is too strong. We've hired remote people who are not going to be moving to New York. Folks who are in California, folks who are in Europe. stuff like that. So it's definitely on the table. I think we're excited by all of this. There's a management overhead associated with it. So the engineering management, for example, for sure has the ability to say like, no, like we don't know how to handle someone in this time zone, and I don't want to wake up at 2 a.m. to do their one-on-ones. So there's a bit of a pushback.
Makes sense.
If they're not in an existing time zone that we have. We'll need to figure out how to manage that growth. But I think if you're interested and excited about this sort of thing, I think reaching out is 100% the right thing to do, and we can try to figure out, if not now, when, or see what makes sense.
Cool. And so for folks who are interested in, grabbing a copy of Materialize, trying it out, like we said, it's super, super accessible. You can get it from an apt repo or brew or whatever, but definitely check out the website first and learn about it. You can go to materialize.com. It's Materialize with a Z. So I think that's the American version. I think Materialize with an S is the British version.
That's right. And
something like that.
The main interesting point, I guess, is that if you go to Materialize with an S, there's a company there. They're a different company. And you might have a very different experience if you apply for an internship there. You might.
Yeah, that's right. So they're actually a fish farm. No, I have no idea. But yeah, Materialize with a Z. And, you can, I'm sure there's a careers page. You could check all of that out. There's a place where you can get, the latest copy of Materialize and try it out. If you have any data that's structured on your machine, you can try out Materialize and actually, so one that, just to be clear, you can like run Materialize over a file, right? I mean, if you're kind
totally,
of testing.
totally, yeah. Text files, like a CSV is a classic thing that you can. We have a few worked examples on the webpage, and one of them, literally, as long as you have an internet connection, just starts getting data from Wikipedia about what are people editing, for example, at the moment. Just starts pulling that down to your computer and has a built-in query that asks who are the top contributors as this data set evolves.
Cool.
And it's just grabbing the data continually once you start the little tasklet. And there wasn't necessarily any data on your computer beforehand, but there is now, and you're just sort of looking at that as it evolves. You could do some other crazy stuff with that too and play with it. Yeah.
Cool. It makes sense. And so if people want to talk to you about Materialize, they can also at you at Frank McSherry on Twitter.
Absolutely.
And we'll post all of that in the show notes.
Yeah, no, for sure. We're definitely active on Twitter. I mean, a thing that I didn't mention, I suppose, is that if you go to Materialize, there's also, for example, a bunch of blog posts, stuff that we've written, just, I would say, slightly more conversational content about what's interesting or different going on in here. And it's a great place to look to sort of form some questions, for example, like this looks great, but and then reaching out in person is totally fine. Like I spend a bunch of my time trying to help work people through like what's different here, or I don't see how you can do that or whatnot. And it's a great thing to do in public. A bunch of people learn from it who didn't necessarily know to ask or couldn't figure out how to frame their questions.
Yeah, that makes sense. I think another thing is for folks out there who are trying to get into maybe like database engineering, the best thing to do is to get your feet wet, using some of these tools. And at some point you might kind of be scratching your head saying, I don't really know how to do this in Materialize, and I don't really know how to do it any other way either. Maybe I'll write a plugin, or maybe I'll fork it and make some changes. And the next thing you know, Frank comes knocking on your door saying, hey, this is some pretty cool stuff. Why don't you come work at Materialize? So, I mean, jump into these projects and dive in, and the source, it's totally open source. So it's an amazing way to kind of learn it. It sounds like it's a very powerful tool for just about anybody.
I would definitely say Materialize, I was supposed to say more than other things, but maybe that's not fair. But Materialize has this cool property that I've so far that you can do some pretty interesting things with it, some unexpected things, stuff we hadn't planned for sure. So I think, maybe, well, as much as other projects out there, getting your feet wet and starting to use it often leads to something surprisingly cool and interesting. And maybe Materialize is interested in it, but even just your friends, or like posting on Hacker News or something, there's some cool things that you can do with Materialize that many of us didn't expect ahead of time and didn't know. Like, oh, well, I didn't realize this was the main problem in sports statistics or something. Like, it's just something we don't know anything about, and you're like, I just put it together and now it does a thing, and everyone's super stoked. Like, you can build some pretty cool and new different things, and telling people about those is wonderful as well. But I think you're right. Just to sort of loop back around to a thing there, like getting your feet wet, whether it's with Materialize or other data platforms, is a great way to start getting a handle on like what's hard, what's easy. What do you find to be most unpleasant. A lot of the folks, the engineers who are at Materialize, are there because, like, literally just asked some folks recently. They're there because this was painful in their previous lives, and if they can make this better, they find that really exciting. But getting that context for like what's hard, what's easy, what would I like to make better, is invaluable.
That makes sense. And so for people who have never worked with SQL before, what do you recommend to them? Are there some, does Materialize link to some like kind of generic SQL tutorials, or is there your favorite tutorial that you point people to?
I don't think we do link to a generic SQL tutorial. That's a really interesting point. Actually, we have documentation on the SQL that we support. So it's as if Materialize had invented SQL. Of course, that's not the case, but that's the way the docs are sort of structured.
Yeah.
I'm not. It's a really good question. Actually, I came to SQL in a very non-standard roundabout way, having done a whole bunch of data parallel computation first, and then looped back around and tried to map SQL onto it. So I wouldn't recommend that path. I liked it a lot, but it took many years. I'm not entirely sure. There's a bunch of, like, I think, for example, Marcus Wynand has a fairly well-regarded introduction to SQL and also skilling up SQL stuff. I don't know the webpage off the top of my head, but I could try to track that down. I have to imagine there's good and bad SQL tutorials. Yeah.
Yeah, I mean, we can add anything to the show notes.
I'll track it down and I'll hand it out and we can make sure it's linked.
Yeah, I also, like you, I kind of learned SQL through I was basically at a place where a bunch of the code was written in SQL, and so that was kind of my way of getting thrown into it. And then I kind of realized post hoc, like, oh, I should have learned this a decade ago. And so I actually I'm pretty sure we've done a show on SQL. It might be dated now, although the standard doesn't change very often, so it's still relevant. But in that episode, I'll see if I can link to that one as well. We'll have a bunch of references. So yeah, definitely check out learn SQL. I guess that's step one. Really, really important, super useful. Like SQLite is very, very accessible. Materialize is very, very accessible, and they will make your life so much easier. And then after you learn SQL, check out Materialize and start using it. So yeah, I think we can kind of put a bookmark here. But Frank, that was a really, really amazing, and inspiring talk. I mean, I feel like I want to try. I'm going to go and grab Materialize right now, and I have some files that I want to see kind of how it works on them. And I think the idea of having kind of a SQL query that works on streaming and running that same one on batch and not having to write two of everything, all of that is super, super appealing. I think people out there have learned a lot and in the past hour. And so I really appreciate your time and you coming on the show.
Oh, it's not a problem at all. I'm happy to be here. And actually the questions were great and really sort of draw out, for me at least, what's exciting and sort of stimulating out what we're doing, why we're doing it. And hopefully, the listeners, some fraction of them agree and like, yeah, that does sound like a thing that I either need or really want or something like that. That sort of then resonates with us for building it.
Yeah, totally. Thanks again. For folks out there, we're working on doing 2 shows a month. So you might be surprised to see this show, considering we already have an April show. So you might be surprised when you're seeing another April show. And so that's what's going on there. We've been working with some really, really nice folks who have been helping us with a lot of the post-processing. And that's allowed us to ultimately produce more content, which is super exciting. And the reason why we can do that is because of your ongoing support. So thank you so much, folks out there who are subscribed on Patreon and people who found out about Audible through our shows. So thank you all so much for all of your support, your emails. We get a whole bunch of new ideas over the past few weeks that we've added to our list. So there's the content is still growing faster than we can consume it, which is really, really important and great. And everyone have a great rest of the month, and we'll see you all next time.
Music by Eric Farndollar. Programming Throwdown is distributed under a Creative Commons Attribution Share-alike 2.0 license. You're free to share, copy, distribute, transmit the work, to remix and adapt the work, but you must provide attribution to Patrick and I, and share alike in kind.